So if we're talking about probability distributions, there are a few basic properties that every probability distribution is going to have. The first one, I've sort of started off here, all of the outcomes in our experiment are equally likely. So we can calculate the probability of any particular outcome or any particular event just by looking at the number of ways the event can occur divided by the number of outcomes in our sample space. And we've been doing this all along to calculate probabilities in Unit 4 or 5. Okay. The next property is that all of the events X that are mutually exclusive. So if we look at the sum of all of the individual probabilities, they all have to add up to 1. We saw that the other day when we looked at our experimental and our theoretical probability distributions. Each individual probability that we calculate by doing the number of ways the outcome can occur divided by the number of things in the sample space is going to be a number in between 0 and 1. So we often express this as a fraction, or we often express it as a decimal. The next key property is something that seems kind of obvious, and we've actually mentioned this before, is that when we're doing this experiment, something always has to happen. The learning guide expresses this as the probability of the null event is equal to 0. Okay. But this is just a condition that needs to be satisfied in order for all of your probabilities calculated the way we calculated them up here to add up to 1. There can't be a possibility that no outcome actually occurs. And another property that we've mentioned before, the probability of an event not occurring, okay, which we have mentioned as the complement of the event, okay, is 1 minus the probability of the event actually occurring. So we've written this before. We've said that the probability of, if we have some event E, if we want the probability of the complement of the event E, that's just going to be 1 minus the probability of that event.